Welcome to this session on data link layer. If you are following this channel and you are watching the videos, then you would have understood that we are covering TCP IP model end to end. So we have covered application layer, we covered transport layer, network layer, and now we are arrived at data link layer. We are here. So data link layer fits here in the TCP IP model. So we have seen that what is important thing to understand or remember in data link layer is MAC. It is dependent on MAC and network layer is dependent on IP. So IP ensures end-to-end delivery across world. So in the world where you are located, that can be figured out with the help of IP. But it will be a network. In which network you are there, that can be figured out with the help of IP. But in that network, correct, if this is a network, these many devices, which device you are located, that is figured it out with the help of MAC, and that is the work done by data link layer. So how to reach to the destination, particular destination, that's what data link layer makes sure. So data link layer lies in LAN, correct? In particular network, you can understand. So simple analogy if I want to give you, right? So IP address, it's like a IP address is like a city or building. Okay, it's like a city or building, and MAC address is a particular flat number in that building or in that city, the particular flat number, apartment and flat number. And data link layer work is related to can be considered as a apartment security and lift system. Whatever work these people do, right? Apartment security and lift system, similar kind of work data layer do to reach to the particular device with the help of MAC. So data link layer has three main responsibilities. Okay, it has a three main responsibilities, which are, first is who exactly receive the frame on the network. So in network we have a multiple devices, right? We have so who exactly will receive the packet frame. Here we are calling it as a frame. Okay, so just remember on this, there is a difference between frame and packet. It's similar, like you have a letter. Okay, you have written a letter. Now you are wrapping it up and putting it into your envelope, correct? So envelope here is a frame and packet here is your letter. So network layer, transport layer, all this layer works on this packet, but since you now have to transfer that packet to the destination, now you need to wrap it, right? Similar like the letter, what postman people will do, they will wrap it into envelope and put some sticker on it, stamp on it, right? Stamp on it, and those stamp as per the hop, right? One hop to other hop, one hop to other destination. As soon as this letter goes, right? Each hop keeps on appending some stamp so that it will properly reach to the destination. So similar thing. So data link layer frame, all other layer above packet. So that's why I am referring here frame. So who will exactly receive the particular frame and particular packet inside? That is the responsibility of data link layer. Second responsibility is how I should frame or package the data. So Ethernet and Wi-Fi understand it, right? The destination Ethernet and data and Wi-Fi should able to understand it. And third is error detection. Detect error in case anything happened in this process of transferring frame to the destination. All these three are very important tasks or responsibilities of data link layer. To achieve all these responsibilities, then data link layer append some header, some trailer, like whatever we talk about stamp, right? So those are kind of things which data link layer add into the frame, make the frame. That all these things data link layer do to achieve these three main responsibilities. So this is an interview question. If somebody asks what are the responsibilities of data link layer, then first is who exactly will receive the frame. That is decided by data link layer. How I should frame the package data, how I should frame the data or package the data, that is decided by data link layer. And during this transfer process, in case any error happened, in case the frame got corrupted, how to detect it and drop it. So that three responsibilities data link layer do. So now coming to frame, let's talk about more about frame. So we have seen that network layer give packet, data link layer wrap it and make it a frame. This we have seen, right? So it looks like this. You will have a Ethernet header. You will have here IP packet, and you will have a trailer. This is your frame altogether. So you can see that this is a packet and it is wrapped around some header and trailer. So this entire thing is called as a frame. Now what is the process of transferring the frames? That we will try to understand somewhat. Okay. So we know that user will open some site, for example google.com. Now it will go to router, right? It will go to router, then it will go to intermediate router of ISP, correct? Then it might travels to other hops in middle, correct? There are multiple hops, and then somehow it is reaching to the Google server. So that's how the data is getting transferred. Now one important thing to understand is every device, every hop, you can call it as a hop also. Hop is a middle station, you can say, right? So every hop has a MAC. Okay, so it has a MAC, it has a MAC address, it has a MAC, it has a MAC, and it has a MAC. This one also has a MAC, correct? And even this one has a MAC. Any device in the network has a MAC address associated with it. So what happens is when our packet travels, right, from this hop to this hop to this hop, the source, we have seen there is a source and destination. So this source is keep on updating, right? Source MAC. So currently source MAC, when it started, source map is this device, correct? When it reach here, when this router forwarded to next one, then the source will be router's MAC. When this forwards to next one, then the source will be ISP MAC. So this way, the MAC address in the frame, you can say it's keep on changing at every hop. So MAC is changing at every hop, and IP, destination IP stays the same, but the source IP changes. Now this statement is very tricky to understand, but just see that we will try MAC and this is IP. Okay, in MAC we have source and destination. In IP also we have source and destination. Now for MAC, since packet is traveling from one device to another device, source will change, because when packet started, source was this one, destination was this one. Now when it arrives here, then source is this one, destination is this one, correct? That way the MAC addresses keep on changing in the frame. In IP, source IP is keep on changing, but the destination IP will be same. So destination IP stays the same, but the source, if you are using NAT, is keep on changing. So that's how this data packet or frame will flow in the network. So now next question comes is how the device gets the MAC address. So we have seen that the device get IPv4 address, correct? Now we want to find the MAC address of the destination. So how the device find is, it uses ARP, address resolution protocol, to get the MAC address of the next hop. So ARP protocol use here to get the MAC address of the destination. So ARP protocol is actually very important protocol. Another concept which is actually coming when we talk about data link layer is of switches. So when we say, right, there are multiple hops in the middle. What are these hops? These are actually switches also. So we have two major components when it comes to data flow. We have a routers, we have a switches. Okay. So switches is actually decide whether the packet should go or no go, right? And router will give the direction. So router will go the direction, okay, this way you go, there will be switch, right? So switch will decide whether it should flow further or not. So that is the main task of router and switches. And data link layer, one more point which is very important is data link layer is not a global. Okay. Data link layer is not global. Not global means, like for example, your packet. When we have a packet, right, that is coming from network layer, whatever information network layer put it, that some information will flow end to end, right, till destination. But data link layer is not the case. Whatever is framed here by data link layer is not present here. At every hop, the source frame is discarded and new frame is created, because we have seen, right, source and destination, both MAC addresses are changing. So data link layer exists between hop to hop. Okay. Between hop to hop only data link layer exists. So IP stays same, TCP stays same, application stays same. But data link layer doesn't stay same end to end. It keeps on changing hop to hop. So this is what actually some key points when it comes to data link layer. So what are things we understood? So data link layer falls below network layer. Its main task is to transfer data from device to device to the end device, right? And what are the three main responsibilities it does? Who exactly will receive the frame? How I should frame the or package the frame, and how to detect an error in case anything happened. So these are the three main responsibilities. Then we understood the difference between packet and frame. How the frame looks like we have understood. Then the complete flow of frame from source to destination and what other things happen in the middle. So this is all I wanted to cover in the data link layer. If you like this video, do share, subscribe and tell your friend about my channel. It will help me a lot. So thank you.